Alright, so we're on to our new unit. Our new unit is geometry. And geometry, you will remember, is the study of what? The study of shapes. So today we're going to be studying both rectangles and parallelograms. Our I-can statement is the area of parallelograms through rectangular facts. So our I-can statement is I can show the area formula for the region contained in a parallelogram by composing it into rectangles. So what we're going to be doing is we're going to be taking a parallelogram. If you don't remember what those are, we'll review it. And we're going to be making it, composing means to make, we're going to be making it into rectangles. Alright, so let's look at this first part. We need to match up each shape with its correct name. Well, I see I have two triangles here, and I see I have two triangles listed up here. So I'm not quite sure, so I'm going to go with my easier one first. I know what this shape is. This is a rectangle. There's only one that has a rectangle. Rectangle has four sides, and each side is a right angle. So if I look, this is a right angle. It's 90 degrees. If I take a piece of paper and put it in this corner, it's going to line up perfectly. So my rectangle is this yellow shape. Alright, let's look at our next one. Our next one that I want to look at is, what is a trapezoid? Well, a trapezoid is like a rectangle. It has four sides, but two of its sides aren't parallel. That means if we extend the sides, they're going to intersect at some point. So look at this right here. If I extend these two lines forever and ever, they're going to intersect at this spot right here. So that means they're not parallel. This shape is a trapezoid. Alright, let's look at this next one. A parallelogram. I'm actually going to save this one for last. We're going to go back to these triangles. So a right triangle, what is that? A right triangle has this keyword right. That means one of its angles is 90 degrees. Or if I take a piece of paper and I put it in its corner, it's going to line up perfectly. You'll notice I have this little box right here. That signifies 9 degrees, or a right triangle. So this shape is my right triangle. This is my acute triangle. Acute means all those angles are less than 90 degrees. And my last one, by process of elimination, or because I know it, is a parallelogram. So what is a parallelogram? Well, a parallelogram is any shape where if I take its sides, its opposite sides, and I extend them forever, they will never intersect. So these two lines will never intersect. And these two lines, the top and bottom, if I extend them forever, they'll never intersect across. It's kind of like a tic-tac-toe board, only slanted. Alright, let's go to our next slide. All of these shapes you see here are quadrilaterals. What's the definition of a quadrilateral? Well, what do you see that they have in common? See if you can finish this sentence. A quadrilateral is any shape that has four sides. So you'll notice each of these has 1, 2, 3, 4. 1, 2, 3, 4. Even this shape down here, 1, 2, 3, 4, has four sides. So let's look at our next one. A quadrilateral is, well, we already know that, has four sides. What is the prefix in quadrilateral, and what does it mean now? Well, prefix means what comes at the beginning. You'll notice what comes at the beginning is quad. So what does quad mean? Well, if I look here, I see something that these all have in common. They all have four sides in common. So that means that quad means 4. Alright, let's look at this one now. All of these shapes are parallelograms. What's the definition of a parallelogram now? Well, you'll notice it's very similar to this, only we've gotten rid of some of the shapes. We got rid of this shape, and we got rid of this shape. The rest are all the same. So what's a parallelogram? Parallelogram is any shape that has four sides and two sets of parallel lines. Remember that parallel line means I can take opposite edges and I extend them forever. I make them go on forever. and they will never intersect. They will never cross. If I do the same to the top and the bottom, they're opposite sides. They never cross. Alright, so now I have my next question. What is the prefix in parallelogram, and what does it mean? Well, my prefix is parallelogram, or prefix in parallelogram. Let's move this down here, maybe. Nope, not going to work. So my prefix is parallel. We already went over what parallel means. It means that they never intersect if they're opposite lines. Alright, let's go to our next page. What are we going to do today? Well, our ICANN statement is I can show the area formula for the region contained in a parallelogram by composing it into rectangles. So I'm focusing on taking a parallelogram and making it into a rectangle. So I can find what? I can find its area. Well, first I need to remember back from 4th grade, what is area? Well, area is how much space something occupies. So I forgot a word here. How much space something occupies. And we find it by multiplying the length times the width. I can also say it's its base times the height. Either one is the same. But I'm looking for how much space do we see. So let's look at this first one. What shape do you see in front of you? Well, hopefully we recognize it's not a rectangle because its sides aren't what? Aren't right angles. This is a parallelogram, not just a simple rectangle. It's a parallelogram. How can we find out the area of this shape? Well, that's easy. I just referred to my previous slide. It's base times height, how tall it is. How long it is times how tall it is. So it's going to be that same thing we've been working with back in 6th grade. We can cut our shape out though and turn it into a rectangle. I can find out how long it is easily. It's 8 inches. But how tall is it? Well, here's where our problem is. I don't know what I'm supposed to be measuring. Do I measure this? I don't know, because a rectangle doesn't have a slant on it. Rectangle doesn't have this part. It has the one that goes straight up and down. So what I need to do is I need to change this parallelogram and change it into a rectangle. Again, going back to that ICANN statement, I can take parallelograms and rearrange them into rectangles. So I need to cut the shape, and where do I need to cut it, and where do I need to move it? Well, there's one spot I can cut it easily. Right here. If I cut it right here, notice what happens. I can take this and move it right there. And now you'll see my shape has become what? Has become a rectangle. And I can easily find the area of this shape, can't I? What did you notice about where we had to cut the parallelogram? Can I cut it anywhere else I want? So I cut it right here. Is there another place I can cut it? You bet. I can also cut it. Oops. There actually is another place I can cut it. It must be on my next slide that I have it. But I can't cut it wherever I want. If I cut it right here, like this, I'm not going to get those right angles. If I cut it like this, I do get right angles. And I can move this part over here, and it will make a rectangle. Let's see, is there another location I can cut it? Yeah, there's actually any places, as long as I get a right angle. Here's another place I can cut it, right here. And then I can take this spot, and I can move it over here. So there's many places as long as I get a right angle. Alright, now here's my parallelogram. We've cut it, we've moved that side over to the edge. Now, how am I going to find the shape of it, or the area, I'm sorry? Well, I'm going to measure its length. So its length is what? Its length is 6. So I'm just going to put a label right here. 6 inches. And now, remember it's length times height, or base times height. They're equivalent. Now I need to find out how tall it is. So let's rotate the ruler. And how tall is it? Well, it is 1, 2, 3, 4, 4.5. So its height is 4.5. Now am I done? No, because if I look at my formula, I have to multiply these two together. So it is 6 times 4.5 equals what? Well, I know 6 times 4, that's 24. And then I multiply it by a half. So half of 6 is 3. So I'm going to get 27 inches squared. Again, what's the area of this rectangle? It's 27 inches squared. How does the measurements, the length and height of the rectangle compare to measurements of a parallelogram? So what it's asking is, how is this part, its length, compared to this part? Well, hopefully you see that they are the same. So since this rectangle was 6 inches, this parallelogram is 6 inches. The other measurement is its height. How tall is it? Well, I see here that it is this tall, which was 4.5. So how tall is this shape? Let's look. If I take this shape and I move it down here, what do you notice about how tall it is? It's the same height. It is also 4.5. So what do we know about their measurements? They are the same. Its height, you'll notice, is from here to here. It's not this slant. It's not the slant. It's from the bottom to the top. And it needs to be that perpendicular line. All right. When we move the right triangle, so we move this portion over to the edge, did the area inside the shape change? Is my area changing? The space that it occupies, is it changing? The answer is no. It's staying the same. Why is that? The area didn't change because both the shapes are the same size. The quadrilateral just looks different. All we're doing is we're cutting the part out and we're moving it. When we cut something out, it's not disappearing if we still attach it to that same shape. All right, the area of the parallelogram is 21 feet above. What is the area of the rectangle in 5 feet? So, if this parallelogram that I'm starting with is 21, the rectangle is also going to be 21. Why is that? It's because both the shapes have the same amount of space inside. You'll notice I'm not losing any pieces up here. It's just being moved around. So it's like you take a donut. If you cut that donut in half and move this half to the other side, am I still going to have a whole donut? Yes, I am. It's just going to be cut in half. All right, let's go to our next slide. All right, what is the formula for the area of a rectangle? Well, my formula is base times height. What is the formula for the area of a parallelogram? Well, you'll notice from our previous example, it was the exact same thing, base times height. So what I need to do now is I need to label the correct length and height on the following shapes. So what is this one over here? Well, this is what? This is going to be its height, how tall it is. This is going to be its base or length. This is going to be its base or its length, how long it is. This is my tricky part. I have two things here. This right here is what? This is its slant. This right here is its height, how tall it is. You'll notice this is the same height as over here. So height is how tall it is from the bottom to the top. Now let's check our work. This is my height, and this is my height. This is its base, but you'll notice what? You'll notice it says length. Can you think of why it says length? The reason why is because they are synonyms. Base is the same as length. And this is also length. Now look at this one right here. What do you notice? It says it's its slant or nothing. What does that mean, slant and nothing? Well, if it's a slant, this is not its height. Height is how tall you are from the bottom to the top. We're not measuring how long a slant is, just how tall it is from the bottom to the top. So this slant is going to be nothing really. It doesn't have a purpose in our geometry today. Alright, let's go to our next page. Why is the height the vertical dotted line? So why is it this and not the slant? Well, the reason why is that if we look back at the rectangle we created, the base and height of the rectangle in the original parallelogram are perpendicular. Perpendicular again makes that right angle. Therefore, the height of the parallelogram is the perpendicular or right angle drawn from the bottom to the top. Alright, find the area of each of our parallelograms below. Note that the figures are not drawn to scale. Alright. First one is 64. Next one is 25 times 8 is 200. Our last one is 84 feet squared. Alright, how could we construct a rectangle from this parallelogram? So notice down here, I have a parallelogram. Why can't we use the same method we used previously? So why can't I just make a dotted line and cut it? Well, you'll notice the vertical dotted line does not go through the entire parallelogram. I'm not starting at the bottom and getting a perpendicular line. You'll notice here my perpendicular line is good. It's 90 degrees, but it's not even touching my parallelogram down here. What if I start by this? Instead of making my line there, what if I do this instead? I start down at the bottom, so I'm touching my parallelogram. I'm going to go up till there's no right angle here. That's not a right angle. So that doesn't work either. So I'm at a problem. So let's put our brains together. And let's look at this. What if I cut this parallelogram into 4 different equal pieces? What would that look like? Well, it might look like this. See if you can figure out what might I want to do next. Well, I know how to find the area of this shape, and I know how to find the area of this shape. So I actually know how to find the area of all 4 of those parallelograms. So we now have 4 parallelograms. How can we use them to calculate the area of the entire parallelogram? Well, look at this. Can you figure out how I get from here to here? It's what I've been working on this whole time. I'm just going to cut from here to the top, or from here to the bottom. And look, there's that right triangle. And I can move this piece over here. So now I have 4 triangles, and I can easily find the area of this whole entire shape. How long is it? Well, I just take its base. How tall is it? Well, now I can easily go from here, and if it was a straight line, all the way to the top. I can easily find its height now. Alright, so let's look at it from the very beginning. Look at how my shapes progress. Alright. Now what you're going to do is, I want you to draw and label the height of each parallelogram. Use the correct mathematical tool to measure in inches the base and height. Calculate the area of each parallelogram. Since you're on the computer, you won't be doing this, so you're going to be doing a small worksheet instead. And you're going to be doing this as a group, so click on the link to the side. Alright, if the area of a parallelogram is 35/42 centimeters squared, so as a fraction it would just look like this, and the height is what? Its height is 1/7. Write an equation that relates the base, area, and height of the parallelogram. Well, here's my area for any parallelogram. The area is base times height. So all it's asking me to do is to take this and plug it into this equation. So here's my equation that it asked me to write. I took its area and I plugged it in, and I took its height and I plugged it in. And then it's asking me to do what? It's asking me to solve it. So now I'm going to solve for its base. I multiply by 7. Remember, I'm doing the reciprocal from equations. So these 7s will cancel out. I'm left with 1b. This 7, I'm simplifying it ahead of time. If I want to, I can do 35 times 7 equals what? So I'm going to do my work over to the side. 400, oops, that's wrong. 7 times 3 is 21, plus that 3 is 24, and then divided by 42. And I know 7 can go into this number because I just multiplied by 7. So what is 242 divided by 7? Well, that is 35. What is 42 divided by 7? Well, that is 6. So that's how I got this part. Then I just need to change this improper fraction to a mixed number. If you don't remember how, here's a short review. 35 divided by 6 goes in 5 times. The remainder of 5, so 5, 6. Alright, so that is how tall, that is how long the base would be if I had a parallelogram. So if my parallelogram looked like this part right here is its base or its length. Alright, closing. Why are the area formulas for rectangles and parallelograms the same? A rectangle is this formula, and a parallelogram is this formula. Why are they the same? The area formulas for rectangles and parallelograms are the same because a parallelogram can be changed into a rectangle. If I cut a right triangle from one side of the parallelogram and connect it to the other side, I make a rectangle. So that's why they're the same formula, because a parallelogram can become a rectangle. Alright, here is your exit ticket. Calculate the area of each shape. Here is shape A, shape B, and shape C. Alright, when you are done, I want you to go on Khan Academy. You're going to do just one lesson. When you're done with that one lesson, you can play math games. Alright, good luck.